Alright, so here's the problem we're going to start with in order to learn how to start using mass-to-mass stoichiometry in a bit more practical way. Okay, so last night for homework, you did a mass-to-mass stoichiometry problem. Now we're going to use it to figure some things out. Okay, it wasn't just figuring out how much stuff goes in or out. We're actually going to use that to identify some things that are key in chemistry. Alright? So it tells you if I have 3.20 grams of iron, actually that should be iron 2, not iron 3 hydroxide. Let me change that, please. Iron 2 hydroxide, not iron 3 hydroxide, okay? If 3.20 grams of iron 2 hydroxide is reacted with 2.50 grams of phosphoric acid that's been dissolved in water, what are 1, the theoretical yield, 2, the limiting reactant, and 3, the excess reactant? And we're going to solve this problem by doing two different but related mass-to-mass calculations. Alright? Got me? So, the product here is the precipitate because it's the thing that we can collect, like you did in the lab. You collected a solid, right? That was the precipitate. So a solid that forms out of a liquid solution is a precipitate. A liquid that forms out of a gaseous solution is a precipitate. That's what we call rain, a precipitation, or snow, or hail. Okay, they're all precipitation. Okay, there's different kinds of precipitation, but basically precipitation in its broadest sense is the formation of a more organized form of matter out of something that's less organized. All right, yes? Yes. So, first thing we do is to figure out what kind of reaction we have going on here. And we have to identify the product we can collect. Alright? To do that, we have to describe the equation as some kind, the reaction in some kind of equation. You have everything you need based on what you should know at this point to write a balanced equation. So please write a balanced equation based on what's here. You may work with a learning partner of your choosing. Alright, so this is the balanced equation. Coefficients of 3, 3, 6, and no coefficient here, which implies a 1. Use an atom inventory to get it done. You always balance oxygen last, hydrogen next to last, and if you follow the procedure you've been taught, that step-by-step procedure, taking it one step at a time, keeping up with all the math, I even write it down. You should too. You will be able to get the equation balanced, but you must take your time and do it strategically. Okay? So this is the balanced equation. We're going to do two different mass-to-mass stoichiometry problems to answer our three questions up here. Okay? We're going to start with the starting amount of 3 grams of iron 2 hydroxide and find the mass of our product. Then we're going to do a second mass-to-mass problem starting with the other mass of the other reactant and find the mass of the product. Okay? So, let's start with 3.20 grams of iron 2. 3.20 grams here of this and 2.50 grams of this. Okay? Houston, you had a question? Phosphate, 2 right here. Alright, so 3.20 grams we'll start with here. Going to put that over 1. Can't get anywhere with stoichiometry without going through Moleville. This means we have to calculate the molar mass of this stuff. Okay? The atomic mass of iron is 55.845. The atomic mass of oxygen is 15.9994. And the atomic mass of hydrogen is 1.00794. This formula has 1 iron, so we're going to multiply that by 1. 2 oxygens, multiply that by 2. And 2 hydrogens, multiply that by 2. We're going to write it over here in a way that keeps all of our digits neatly lined up so we can add effectively and find out what our significant and insignificant digits are.
On the
794 down here.
yes, sir.
794. Mm-hmm. All right, I have an empty slot in this column and 2 empty slots in this top column, meaning 2 digits on the end of here have to be rounded off. If you don't keep your digits lined up neatly, you won't know that. That's why I ask you to keep your digits lined up very neatly. Uh-oh, I made an error here somewhere. Yes, you can get some water. And this is grams of iron 2 hydroxide, which we're going to round off to 89.85. Oh, 6 rounds that up to a 10, which rounds this up to a 6. 89860 grams of iron 2 hydroxide. And that's equal to 1 mole. Really? Did I put something in my calculator incorrectly? 55.845 plus 31.
It was probably rounded up. They rounded up.
Okay. I mean, I could have hit a button wrong. That's why you want to do your math twice.
Well, Julia said she got something.
Okay. Then you probably just hit a button wrong. Okay. Now, this is our equality statement for molar mass. Just this part here on the left is the molar mass. But we're going to write it to show what the molar mass is. And the molar mass is 1 mole of that same substance. So that with this equality statement, we have what we need to build a conversion unit. Matching the units and species here with what I put on the bottom, I have 89.860 grams of iron 2 hydroxide. And 1 mole goes on the top. 1 mole of iron 2 hydroxide, the other side of the equality statement. Okay? The next step is to come up with a molar ratio. I want to cancel units and species though because I want to cancel as I go. Cancel as you go. Alright, this next step is the molar ratio step. We want this number of moles of iron 2 hydroxide on the bottom here because it matches this the units and species here. 3 moles. Oops, that's moles. Actually, I don't need even the solid on the end of it there for this, just the species. Huh? Yeah, because there's only 1 mole here. That make sense? Okay. You know, if you're talking about something else, you're not paying attention here. And that's not good. So now we can cancel moles and iron 2 hydroxide. And we've canceled everything but moles of this, but the question doesn't need moles of this, it needs mass of this. So I need another molar mass calculation to go from moles of this to mass of this. I have to calculate the molar mass of iron 2 phosphate now. Okay? What now? And it's always equal to 1 mole. Alright? And we have what we need to be able to go from moles of this to the grams of this. By putting 1 mole here on the bottom because it matches moles of Fe of iron 2 phosphate here. The moles match, the species match. And we're ready to put the math in the calculators. Alright, so what I've told you before, to speed this up, to make it go faster, you're going to multiply this times this, hit enter, divide by this, hit enter again, divide by this, hit enter again, that'll give you the answer. Okay? And round that off to 3 digits because our starting amount over here has 3 digits. Slide over here so you can see. And we got 4.24 grams of iron 2 phosphate. Okay? That's the first of the two. Now we've got to calculate from the other amount, 2.50 grams. 2.50 grams of phosphoric acid. Okay? And we're going to go to the same product because that's the one we're collecting. What we're collecting at the end is the yield of the solid. And this is the only solid we're making. What? That's what we're going to make. We're going to find the theoretical yield by doing this. What? Yeah. So put your other amount over 1, 2.50 grams.
But is it the exact same equation?
No, because you're going to be starting with phosphoric acid this time.
Yeah, you just change the starting amount, that's it, all the rest.
That and the molar mass in the beginning, and then the molar ratio has to change. I'll show you. Well, if I zoom out too much, then people won't be able to actually read what's here. Has everybody finished writing this down? Okay, so now we're going to start with this new amount over here. Okay? We had 2.50 grams of phosphoric acid. That's what we're going to start with here. We've got to find the molar mass of phosphoric acid and build a conversion unit. Okay? For time, I'm going to go ahead and give it to you. Is that okay? The molar mass of phosphoric acid, 96.9872 grams of phosphoric acid equals 1 mole of phosphoric acid. Now, I don't want anybody to ask me later on, where'd you get that number from, Mr. Tedder? Where'd I get it from? I just told you. I did it earlier. I'm not showing you the math again because we've already done 2 molar mass calculations, okay? All I did was calculate the molar mass for this. Got that? All right. Grams are going to cancel. Phosphoric acid is going to cancel. We need a molar ratio now for phosphoric acid and iron 2 phosphate. So how many moles of phosphoric acid do I put on the bottom? 3. And how many moles of iron 2 phosphate do I put on the top? 1. There's an implied coefficient of 1 there. We've already calculated the molar mass for iron 2 phosphate. We don't have to do it again. It's already been done. All we got to do is use this same conversion here because that's the same one we need. Does that make sense to everybody? Please don't just write stuff down because I'm writing it down and not understand why we're doing it. Everybody understand why I'm going to just take this and write it down here? Okay. I hope so. Oops. It's supposed to be just FE3, not a parentheses yet. Yeah, that's true. Alright, moles of phosphoric acid cancel, moles of iron 2 phosphate cancel. We're left with grams of that. And we do the math. Same way. Multiply everything across the top. Alright, so we get 4.60. If y'all hang on just a minute, we'll have this answer cleared out. Yep. Alright, this is all the math you need to do. Are you going to watch the video, Dylan?
I will.
You are? Okay, alright. We're almost done here. Everybody got this? Oh, we're not done yet. We got problems with even more work. So just... Okay. Pay attention. Pay attention. Is everybody paying attention? Everybody focused? The amount that's less of this product is the theoretical yield. The lesser amount of this product is the theoretical yield. This is the theoretical yield here. Okay? Got that? The species we started with to calculate that amount, the species we started with to calculate that amount, this species right here, this is your limiting reactant. Okay? The species you started with to get the greater amount, this species right here, the species you started with to get the greater amount, that's the excess reactant. You got that? Now, let's give you a homework problem. You now have all the math skills you need to answer every post-lab question except the very last one. You now have all the math skills you need to answer every post-lab question except the very last one. Okay? So this is the same kind of math you're going to have to do on the post-lab to get that final answer, those final answers. There's one more little thing to do to get all those answers. Okay? Any questions? A lot of rustling around putting stuff up, and I haven't told you to pack up yet. I hope you're listening. You're held to it whether you listen or not. Okay? Y'all have a good lunch.